Okay, so our next presenter comes from the Department of Occupational Therapy, the Occupation and Rehabilitation Science Program, Mei Heng Lin, and she will be speaking about modeling the neural and behavioral interrelationships of error monitoring.
Have you ever made a mistake and said, oops, there is something going on in your brain at that moment? While making mistakes is unpleasant for most people, it's my primary research interest. For my research, I use electroencephalography, which is EEG, to understand what's going on in our brain when we make mistakes. If we put an EEG cap with sensors on your head, as shown in the figure A, we can pick up the electrical signals generated from your brain. Now, imagine that you are sitting in front of a computer and you have to press different buttons based on the pictures that you see. From the moment that you see the picture to the time that you press the button, there are many neural processes going on in your brain. Your brain starts with sensory recognition and registration, and then your brain discriminates the pictures so that you can make a correct decision and know which button to press. This all happens very quickly within a second, and these steps are well connected as a chain. One significantly predicts the next one, as shown in the figure D. Interestingly, things are different when we make mistakes. I found that when people press the wrong button, their neural processes break down at a very early stage between sensory recognition and registration. It happens around 200 milliseconds after you see the pictures, as shown in the figure E. Moreover, our brain shows a negative voltage deflection after we recognize that we made an error, as shown in the figure C. Then, our brain will activate a mechanism to modify our ongoing behaviors and make sure that we can perform better next time, as shown in the model in the figure F. However, clinical populations such as adults with brain injury or children with attention deficit hyperactivity disorder, which is ADHD, demonstrate different neural processes compared to people without neurological disorders. My dissertation research will focus on where the model breaks down for children with ADHD. Understanding at which phase of neural processing they start to differ will help to develop more effective and targeted interventions for them. Therefore, next time when you make an error, don't worry, your brain will pick it up and you'll learn from your mistakes. Thank you.